Okay, hello everyone. Today I've got an interesting tutorial that I've been wanting to put together for a little bit, using geometry nodes as an animation controller for a floating object. Something that'll actually simulate buoyancy. So before we jump into Blender, first thing I want to do is go over a couple of the concepts. That way we have an idea of where we're starting with. That way we know what we're going to be setting up once we get into Blender to create this. The first thing we're going to go over is all of the reference points that we are going to need. Because we are using geometry nodes, we need external references to correspond with to be able to do the math that we need to edit the objects. So for this rig, we're going to need 8 empty points as reference. So the main reference point is going to be just the center of the object that we can use to move the whole rig around the scene. Will actually allow us to position the object where we need it. We'll also control the main Z rotation of the object. Next couple points we're going to need is a forward vector and a side vector. This will allow us to reference a flat plane of our forward direction and our side direction. That way we know where the object would be in a flat plane, and this will actually give us reference, when we go to calculate our angles for the other points. Then we've got a center reference for the boat itself, or raft, or whatever it is you're floating in the water. Then we got a front and back reference and a left and right reference. These points are actually going to be projected down onto the water and will actually move up and down as the water adjusts, over the lifetime of whatever animation, whether we're going to be using the ocean modifier, which is what I'm going to set up today just because it's quick, or if you're doing a full-on water simulation. The next thing we need to go over is the calculation for the angle between two vectors. So the way that this works is the angle is going to be the arc sine of the dot product of the two vectors divided by the length of both vectors multiplied together. Pretty simple equation, and it's going to be easy to get all of those values out of all of our reference points and be able to calculate the angles that we need to adjust this raft with. And then the very last thing we need is the general understanding that as water moves around, waves and stuff are going to be, going all over the place. So the outer 2 points, the midpoint in between those 2 points, is actually going to change as, the angle between the front and back or left and right go up and down. Well, the midpoint could be higher or lower than the midpoint between those outer 2 reference points. So what we need to be able to do is determine which is the higher of those 2 midpoints, so that way we know where the middle of the boat needs to be. Because if points are here but the midpoint's up here, we don't want the boat through the middle of that. We want the boat floating at the top of that crest. So we'll set up a thing that will calculate between those 2 points. All right, so let's jump into Blender. Got a basic scene here. Gonna go ahead and delete my, can't see past my mic. There we go. Delete that sphere. Adjust my mic so I can see my keyboard a little bit easier. All right. And to start off, I'm going to go ahead and bring in my object. So I've got this lovely little raft here, low poly raft. And then the next thing that we're going to do is we're going to start building our reference empties. So we need to go through and add a bunch of empties. So let's go ahead and add one. And you can change these, that way you understand which references are what. So my main one I'm going to have as, adjust my mic real quick. Keep cutting in and out. First one I'm going to add is going to be just a simple sphere. Bleh. Size that down to just a quarter, and I'm going to put that, and let's put that 5 meters up. Yeah, 3. That should be fine. Okay. Now the reference ones are, like I said, simply for reference, so they can be any height off the ground. And this would just make it easier, so when you're trying to position your object on the water, you can clearly see where it's going to be. Because the interesting thing about this rig is the actual object doesn't move. The vertices and points of the object are going to be relocated by the geometry node. So the physical object doesn't need to go anywhere. It actually stays in the center of the scene the entire time. Just the rig moves around and moves those points accordingly. All right. Let's go ahead and duplicate that, and we're going to move it on the y-axis. 1. We should also start naming these, that way we know. So I'm going to say origin. We're going to call this one forward. Forward. We're actually going to parent this, but the origin is the root object of this entire rig. That way I can just grab the origin, move it wherever, or animate it wherever. Alright, so let's go ahead and duplicate it again. Move it on the X by 1. And we're going to set that as side. Now we can set these to rotate them. That way they're pointing the correct direction. That way I know. Go negative. Work with me, keyboard. Let's set that as tone is a little easier to see than that little. Set that as cone. -90. Okay. So that will be our references. Oh, I was actually setting those up wrong. So, change the name on those. Forward one is actually the side. That is okay. There we go. Now we're set up correctly. All right. So now we need the 5 points for below. So we'll duplicate this. Bring that down to 0. And we're going to say center reference. Duplicate from there. Go on X. Front. Reference. Hit that again. Go on that X. -1. Rear reference. Duplicate on the Y one. That's going to be our left. Reference. And one last time on the -1y. And that will be our right reference. Okay. This is now our control rig. So if I grab this, hit Shift Z, so I can move it just on the X and Y. You can see I am now moving the rig wherever I need to. And if I rotate on the Z, I can rotate it so that way it's pointing in different directions. So now I need to attach those points and set up all the math so that I can control my little raft. So what we're going to do is going to go into geometry nodes and create a new node group. For this, we are going to need a geometry transform. And that's it. Well, that's not it. That's the basics. This is the only node that is actually directly affecting the geometry, but there's a lot of math that we got to do to get there. So what we want to do is bring in all of our reference points. So we need to bring in the other objects. So we need to go to input, object info. And the first thing we're going to bring in is our origin. I'm going to duplicate that, bring in our forward vector, duplicate that, and bring in our side vector. Where are you? There you are. Okay. Apologies. All right. So there's a couple different things that we do need from here. And so we are going to go ahead and set that up and then create groups. That way we can kind of keep this from getting super chaotic. So first thing we need, math node. Correction, vector math node. And we need a subtraction. So to calculate any vector, you need to subtract the two together. So you subtract A from B, and it will give you a new vector. So dependent on the origin point and the point of these two vectors here, we can calculate where they are anywhere on the scene. So we want to take the location of the forward vector and the location of the origin and subtract them. And that gives us our new forward. Then we want to do the same with side vector. And that gives us forward and side vectors regardless of where we are in the scene. Next, we want the length of these. I will go ahead and duplicate vector math and get the length. This one, duplicate and get the length. This one. Okay. And then the only other thing that I need from these vectors is the rotation of the origin. But I only need the Z value of that rotation. So we'll go ahead and get a separate XYZ. Grab the rotation. Grab the rotation. And now I've got a Z output. So to make this a little more useful, we're going to go ahead and group that. Don't need any inputs because we've already got that. But we are going to take the forward vector, forward length, side vector, side length, and Z rotation. And go in and rename these so that we know which ones are what. Forward. Here. Forward. Length. Side vector. Side length. And Z rotation. Okay. All right. Now we've got some math to start with. This is all of our reference math. The next thing we need is to start finding some angles. So let's go ahead and grab input object info and start with our forward back. So front reference, take that, rear reference. So we need a couple things from here. So we need the entire vector. So again, we're going to get a vector math and subtract the location. We need to get the length of that vector. We also need a midpoint. So the way that we're going to do the midpoint is we take the two vectors, duplicate that, we add them together. And then we scale that by 0.5. Basically divide the whole thing 2. All right. So one of the things that we're going to do is I'm going to simplify this again, but before I do that, I'm going to shift right click with node wrangler. That way I have those points combined, because when I group this, I can control X on that, the way it lines that up. I can rename these inputs A and B. And now I have AB, AB length, and AB midpoint. And this just makes it easier, so when I grab these two, actually grab all of this, duplicate it, I can switch these to the left and right. And math is already set up. Okay, so now we need to find the angle between our reference and the control points. So, going back to that equation, you need the cosine of the dot product of both vectors divided by the length of both vectors multiplied. So, we have the length, we have the two vectors. Let's get math. We're going to take the dot product of AB and our forward vector. We are going to get normal math multiply length. We're going to get another math. Let's just take this one. Divide the dot product. By that. Okay, and then we can duplicate that again, and we get the arc cosine of that. Okay, now we've got something to work with. So what we're going to do now is take this and get a combine XYZ. And this is actually going to control the Y value. So this is the front and back, which is on the X-axis. We got our front and back. So as these adjust, this is going to control the Y rotation of our raft. And while we've got that, we know that the Z rotation of our origin point is going to control the Z rotation of our raft. And we're going to plug this into the rotation. All right. Now, all we need is to test it. So, what we should be able to do is grab one of these points, gonna grab it on the Z-axis and move it up and down. Uh-oh. Whether it's positive or negative, it is moving the wrong direction. So, when you do the arc sine, or arc cosine rather, of these things, it will only give you a positive value. So what we need to know is what is a higher point. So before I go too far into this, what I'm going to do, create a new node group. Change these to A, B, A length, B length. Okay. We have the inputs for our two vectors and our output. We just need angle. All right, so how are we going to determine this? Well, if we know that one point is higher than the other, it's going to be either positive or negative. So what we need to take is another separate XYZ of A. Actually, before I do that, I will need that, but let's grab vector math and set this to subtract. So if I subtract those two and then separate XYZ, the Z value will either be positive or negative depending on which is higher. So I just need to know whether it's positive or negative, which we have a function for: sine. Not sine, but sine. Sine with an N. So we take the Z value of that subtraction and put it into sine. And that will give us a positive one or a negative one, depending on if it's a positive or negative. And then we should be able to just take that and multiply it by that sine. All right, and as we go to test this stuff, one of the things you can do is you can pin your geometry node setup. That way when you start selecting other objects in your scene, it will not disappear. So I can select this, grab it on the Z, And it is still not working. I think I actually do need to separate this beforehand, so we're going to go ahead and delete that. Duplicate that. Okay. So I need to separate XYZ and I need to subtract the Z's directly. That and subtract. That. Okay. Now if I grab it on the Z. Okay, now it's at least working correctly, but it's going in the opposite direction. So there's a simple thing we can add. Okay, so this is currently moving opposite of the way we need it to. So what we're going to do is we are going to add another multiply. And I'm going to actually connect this to the input of this group. And I'm going to call it inversion. Now, with that inversion value, I can either set this to 1 or -1. So right now I need it to -1 because now if I try it, hey, now it is following the direction that I need. And same thing if I move the back. All right. So now I need to duplicate this. And that is why we build a nice little node group, because it just makes things so much easier. So we've got our left and right, our side reference, side length, and our control point length. And that will give us our X rotation. Now let's see if we need to invert that one. Nope. Inversion is not necessary. We'll set that to 1. There we go. Now those are working. Okay. So we've got our angles working correctly. If I grab, rotate this on the Z, you can see we're controlling the direction of the boat. If I move these points, the boat is rotating correctly. All right. Now for the next piece. So I need the origin location, or not the origin, but the center control point. Now we could just set this location close outside from I could just set that as the new translation. And it will move everything around. But remember what we talked about the waves. If these 2 points are higher than the center point because of a crest of a wave. I want the midpoint of those 2 points to be what actually sets the location instead of that point, but only for the Z value. Alright, so we need to get the midpoints, and I actually want to average out the midpoints between the 2 things because I've got left and right and forward back. So I'm going to get the average of those 2. The same thing we did before for math. Add those 2 midpoints together. And then scale those. By points. Okay. Alright, so I need to know which of these 2 is higher and which one is going to take over as the control point. So we are going to take separate XYZ. And we are going to duplicate that. And again, we are going to subtract. The values from each other. So, if this is higher, this will be a positive value. If this is higher, this will be a negative value. So we just need to know which one greater than 0. And we take so if this is greater than 0, this one is the proper vector. So we need to scale by that value. But since this one is not, we need to scale it by the opposite. So in order to do that, we're going to take a subtract node and do 1 minus that value. So if this is 1, this is 0. If this is 0, this is 1. Scaling this. Now we can add these 2 together because one of them is going to be scaled by 0 and therefore be 0, and the other will be itself. And so pretty much whichever one is 0 is going to not influence this add. So now if I grab one of these points, you can see that it is moving by the midpoint. However, if I drop it below the midpoint, control point is the same here. Try it here. There you go. And it is taking an average of those points. Calculate that. So we pretty much have all of our nodes set up correctly. So we're ready to actually start setting this up for a scene. So what we're going to do that is create a plane. And we don't need to really do anything with that plane because we are going to do a simple ocean modifier. Ocean. Let's make that a little bit bigger. Let's even go into wireframe, that way we can see it a little nicer. I'm going to set that as hashtag frame divided by 4. That way we have a nice animated ocean. All right, so how do we make our control points stick to this ocean? Well, that's actually pretty easy. Go to your empty, go to object constraint, and go to shrink wrap. We're going to set that as the plane. We're going to set it as project on -Z. So you can see when it hits 0, it kind of stops because it doesn't want to do anything. So what you can do is, since this is a projection based thing, we're going to take our reference points and move them up so they are above the ocean. Now we go through and take each one. Actually, I did the right one first. Can't remember if I can just link that. I don't think I can. Nope. So I have to do it manually. So go through, shrink wrap, plane, project, -Z. 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 All right. Our raft is now floating on the ocean. And let's just give that a quick material. Color, roughness. There we go. All right. Now we can take our control rig, move it anywhere, and our raft will float. And there you go. Buoyancy rig complete. And the nice thing about the way this is set up is if you have a longer boat, you just take your control points and set them out to further points. If you have a long boat, you can move the left and right a little closer together, and then the front and back further out, so that way it matches up with the longboat or canoe or, full-on battleship. The other nice thing is if you need to control characters on this raft, you can add another empty. Actually, let's pause this. I need to focus on there. Okay. And then I'm going to shift right click, add an empty. set that as circle. We can go into here. Oh, I forgot. All our points are back here. Do this before I did. Move this back to the middle for now. Let's grab a couple of points. A new object. Ew. Edit. Yeah. I want this. Okay, I remember. Alright. Modifier. Get rid of the hook. Okay. Go into edit mode. Grab some points. And we're going to make a vertex group. Assign those to vertex group. Alright. Plane. Reference. We're assigned. Okay. You are going to go to okay. I think that should do it. Grab Z. Oh. Track 2. Aldo. There we go. There we go. Okay, so now you have a little floating reference point above your boat, and you could set that up a little bit better where it's actually centered on the top surface of your boat, or you can create a plane object or, you know, whatever you want, and you can attach your animations to that. So if you have like a little person standing on this boat, they can be tied to that. That way, as the boat bounces up and down, they are bouncing up and down with it and being able to animate still. So if you want to add, you know, animation rigs and stuff like that, you can use that as an origin point to hold them onto the boat. So As long as they are a child of that empty, they will move with the boat. And there you go. Now we have a boat that we can sail around the lake. And you can create paths for this origin point to follow. So if you wanted to follow a specific path as it's, going through like a river run or, anything like that, you can animate that point and it will move your boat around as long as you have that empty. Huh. Don't know why it's not moving with those. I'll have to debug that later, but the main thing is to have your control rig. That way you can control where the boat goes. And if you have to do any layered animations on top of it, you may have to do some tweaking to get that to work completely correctly. But that's how you can use a bunch of reference points and geometry nodes to simulate a boat floating in the water. All right. Hope you guys have a good one, and see you later.